Hi everyone, welcome back to my messy lab. Today I have my latest purchase is an HP power supply, is a triple output power supply, and well, this is declared non-functional. It's well having a lot of sticker residues. I just opened the box right now, so I want to open it up and see how it's inside before to apply any power. And well, let's see. Okay, there is also a huge sticker here. Yeah, let's see if is alive or not. So I have just opened the unit and well, it's not in a real bad shape. It's a little bit dirty inside, but not so much. And as you may see, okay, maybe now you can see, the unit is, the input selector switch is for 120 volts, so I will switch to 220. Then I will connect to my variac and I will slowly increase the voltage and see the behavior while we will see the output. Unfortunately, I have noted that it's missing one screw here and one rubber fit, which is make it very annoying because it's tilting on the table. I really hate this. Instruments with the missing of fit, but well, what shall we do? So let's try to see if the instrument is alive or not. I will check the fuse if it is the right one, and then if in the end we will have a functioning supply, I will give a small restoration on the front panel. So let me check fuse and connect it to the variac. Well, before attempting to connect it to power supply, I get a more in-depth view, and it's quite dirty, so I prefer to clean it before to connect to the power supply. And then there is a sticker, oh, made in Singapore. Well, probably this was living somewhere inside. I will find where. So I will take my vacuum cleaner and with a brush I will clean the inside, and then I will connect it to the variac. The removal of the fuse is almost impossible because it's so tight that you cannot turn it. Probably I should have used a plier, but without the breaking of this, it's not possible. So I prefer to leave it as it is, since I will crank up slowly the variac and see the amount of current that is draining. So I don't want to break the fuse holder just for check the fuse. And I believe that this is still the original, so I hope it's not blown out. Otherwise it's so hard that probably I have to loose the nut and remove the fuse holder from the unit, because it's not possible to make it open. It's arrive at this point and you cannot unlock the bayonet locking system. So very, very hard. Okay, let me clean it up and try to see if it's working or not. All right, so I get fast cleaning inside the unit, so the majority of dust has been removed. I have switched the input selector to 220 volt. So what I want to do is to test the fuse if it's open or it's good. Yeah, fuse is good. So okay, we can go ahead with the connection to the variac. Let me prepare everything and see what we will have. Okay, so my variac is connected, so I will slowly crank up a little bit the voltage. The voltage is almost 50 volt right now, so let me connect this to here. We are not reading nothing. I think that my setup is not so good. Well, we could also make like that and see if both are going as they should. So we have plus and minus. So we should read 40 volts. Okay, this is fixed, so the same. This is the tracking between the plus and minus volts. When this set it to fixed, they are at the same volts. If you reduce the ratio, you can reduce up to 10%. So you will have the minus voltage that is 10% less than the plus voltage. This is, if I'm not mistaken, what I have understood reading the manual. Okay, so actually, if I move the voltage output potentiometer, yeah, it's doing something already. Still, if we need to crank up voltage, because we are at 80, maybe 90 volts AC, and okay, this is the 6 volts. Okay, let me prepare a different setup a little bit, and I'll be back. So this is my new setup. I'm monitoring both the 6 volts output, that if I turn the potentiometer, I have 2 millivolts of difference. Okay, the switch is doing something. You see the needles are moving up and down. So let me crank up a little bit more the AC volts, hoping that everything remain okay. So we are now seeing +5, but actually here we have 23. Okay, let me reduce to the maximum. Okay, so we have 18 volts, since so I should be at 9 volt. So now 12 volt, and here is reading 5 volts, and Okay, this is from 0 to 3 volts. Yeah, this seems okay, but this seems quite high, eh? And it's not possible to go to 0. So let me crank up a little bit more. Okay, light, power light is glowing now. Okay, so I still have high voltage, but probably is as it should be. So it seems that this regulation does not put to 0, but we start from 11. Let me see if I can remove this sticker. Ah, very good. I hate this way to put sticker in the front panels. So, well, here this is going down, so this is not okay. So minus 20 is going to plus 20. Okay, it seems that the negative volt it's already to the maximum and it's not regulating. So I think this is the reason why they say that is not functioning. Okay, so now I understand. The lower scale is for the 6 volt and is going from 0 to 4.5. Now it's okay because the input voltage is 150 instead of 220, so that is normal. So plus 20 volt, the meter is to plus 20, and I can adjust from 0 to 15. But if I switch to minus 20 directly to 20, 22, 23, 22.5, 23 almost. Yes, it's almost 23, and it's not regulating at all. So it seems that is at full voltage. So I think we need to check what is going on in this negative section of power supply. So let me see the schematic, what is it. So as we can see, this is the section of plus 20 and minus 20 volt regulators, and this is the plus 20 regulator, which have the voltage regulation, and the output of this regulator we know that is correct. So, but if we follow this line, we go directly on this differential amplifier, which should regulate the minus 20 volt. And this is the tracking ratio. We have two positions, fixed and variable, in order to have a precise level of plus and minus voltages, or an offset between the two voltages. And the offset can be regulated by this potentiometer, which is right this one. So there is a switch, and at the end of the stroke, of the turning. So turning back, we have a variable tracking adjustment in order to have an offset between plus 20 and minus 20 volts. So since we have these regulations that is not working, actually what happened that if I go to variable, and if I pull this resistor close to the minus 20, it happened that this start to regulate, and I'm able to go to 0 on minus 20. But we also have a weird behavior, since, and I will show you in a moment, when I'm going, close to the end of this potentiometer, turning counterclockwise, I'm seeing on the current meter a little rising of the needle. So I believe that I have some problem with this IC, because this is a U2, is a dual comparator in one contentor. So U2 is right over there. So I think that I need to check if by regulating the plus 20 over there, we have some difference here. Maybe we can have an open resistor here. But I believe that there is something very strange, since this is the current limit section of the IC, and it should also go to the meter from this line. And now we cannot see, maybe if I can move, is on another page, but well, we should not see any current. So it seems that pulling this to work hardly, we have some current maybe through the IC itself. So let me check about the voltage here and see what's happened. And I also need to see if I have some of this IC with me, in my hand, and maybe we can try to swap it and see if we make the difference. So let me make the setup and see what's happening. This is my setup. So I'm going to measure exactly on this point, since I have this switch available right here, and this is the potentiometer, and as you can see, there is a ceramic IC, which is the resistor array which contains these two resistors. And so let's see what we have exactly on this point. So let me switch on. As you can see, it's going to full scale. So I'm going to measure over there. We have 133 millivolt. So if I go to, let me see if I can make like that, and change the regulation. Okay, so this is the maximum. Okay, so we have 139 millivolt, and to the minimum we have 132. So it's clear that we have some regulation. So let's see if we can go ahead. Okay, so I want to see the behavior when I go to fix variable ratio. Okay, so as you can see, yeah, the voltage is going down very quickly and is rising up the current. Of course, no load. So, well, the goes to the minus. Okay, so it seems that okay, so it seems that here is generating for some reason some current. So I think there is a leakage inside this integrated circuit, which is right this one. This is the driver transistor, and this is MC1458G, and it happened that in my stock I have 3 brand new to be opened. So let's try to swap it and see if this can fix the problem. Well, I have replaced the IC, but it doesn't fix the problem. This is the brand new one, so I have reinstalled the original one, and well, with the new IC nothing changes, so completely the same behavior. And as you can see, it's going to in the minus 20 range of the meter selector. It go to full scale, so we are at the same point of the beginning. Well, at this point I decide to make a different setup and see if I can measure some ripple on the pin number 3 of the IC. And this is my setup, and look what I have. A square wave. That's unbelievable. So the same square wave, I moved the probe from here to the right to the output. So I have my ground on minus and my probe tip on common, and this is the output. Unbelievable. I have a 28 kilohertz square wave. That's really weird. I believe that for some reason it is self-oscillating. So, well, what I could do now, trying to put a capacitor to the output. So let me, this is the minus 20 range. Put a capacitor between the terminals of minus 20 volt and common. So this is, let me see, it's noisy. Let me go on the magnifier. Okay, oops. So this is 10 microfarad, 50 volt. It's almost impossible to make it. Okay, so in the other way. Okay, so let's try to put my positive to the common terminal and my negative to minus. All right, yeah, look at that. It's go to 0. Let me see. I still have some. Oh, okay. So the output now is clean. Okay, so let me try to regulate. And it works now. Yes, so yeah, we still are at minus 20 range. So let me check the schematic and see what can cause this, because I believe there is a capacitor right to the output, and should be one of these three capacitor in the vertical position here. So let me check the schematic. Well, I found the output capacitor, and let's see what say. Look at that. And 39% of loss. It's 0.14K of ESR, so it's 140 ohm, and is let's say 400 nanofarad, but it's supposed to be 180 microfarad. So this is an open capacitor, and in fact I have replaced it with one of 220 microfarad, 63 volt, and so look at that. Look at that. Now it's completely working. So it was simply the output capacitor. So this is plus 20, and it's regulating as it should, and this is the minus 20, and it's regulating as it should. So back to work. Now what I will do, I will grab the schematic, so I will show exactly what I found. And actually this capacitor is in series with this resistor, is a 0.25 ohm. The resistor is fine. It's simply open the capacitor that were here. So, well, for the moment is it's good. I mean, I'm happy to have the power supply back to life. So what I will do, I will grab the schematic, so I will show exactly what I found, and after that I will give a very nice cleaning to the unit. So let's go ahead. Well, before to go ahead with any other thing, I wish to see the balance between plus and minus voltage. So with this I'm checking the plus 20, and with this one I'm checking minus. So minus 20, it's minus 24.64. This is at maximum, and here is minus, and here is plus 24. Well, it's a little bit moving, but it's almost the same. If I go down here, let's say to 10 volt, let's see. Okay, 990. Look at that. Minus 90, 91. So it's really balanced. It's really nice. And if I change the tracking here, so let's say to the middle. So here still have 990. And here we have 562, minus 562. And I can go down to 0 almost. Yeah, it's millivolt. So it's minus 2 millivolt. If I go up, it's minus 2. It's minus 4.76. And we should go, let's say, to minus 4. Yeah, okay, let's say minus 5. So it's not exactly in the half scale here, but okay, I mean, the important thing is that when it's fixed, it's the same. So this is a little bit moving, 90, 91, and 991 minus. So, well, it's really precise. And I have checked for any kind of ripple in the output, completely clean. So, very nice. So, let's go ahead with the cleaning, and I will show the schematic. So, this is the section of minus 20 volt, and as I was remembering, there is one electrolytic capacitor right at the output in series with a 0.25 ohm resistor, and well, this is the one that I found open, and the cause of the malfunctioning of the unit. So it seems that the filter action of this capacitor will eliminate the oscillating on this circuit. So it's clear that having this capacitor open, the power supply was not working anymore. So this is the final result. So the power supply is completely reassembled and is working as it should. What I need to do is to get adjustment on the current limit circuit, since I don't know if still is within the spec. Those three trimmers are to regulate the current, maximum current of the three outputs. So, well, as you can see, it's missing one small cover here to the knob. I will manage in the future to find it. And as you have seen, I have manufactured the missing lower fit, so it's now not tilting anymore. So, well, I'm pretty satisfied. What I'm thinking to do is to add a lead, maybe green color, up to those meters, since when it's closed, I mean when I put the top cover, well, it's quite dark in the scale, meter scales, since they are quite deep in the front panel. I mean there are, let's say, 6 millimeter to the glass, but to the scale maybe 1 centimeter from the bezel here. So, well, it's quite difficult to read the meter. So maybe I will manage to add maybe 2 small green leads over there, and see if will be more visible and maybe also more pretty. So I will do this small modification and do the adjustment procedure, and then I will test the unit with some load. So let's go ahead. According to the service manual, the output of minus and plus 20 volt should be regulated at 0.55 amps through the relevant trimmer. This is for -20 and this is for +20. So what I'm going to do is to perform the adjustment of the -20, and it is declared to turn to the maximum voltage, and we are having 0.54, which is almost perfect. So just try to increase a little bit. Okay, too much. Yeah. No, it's, I mean, I can leave as it is. So what I'm going to do is to change to +20 and see the current limit on that section. So let me change the position. Okay, I have just changed it to +20, and as you can see, it's regulated to 0.44, so it's a little bit out. So I'm going to increase to 0.55. That's okay, that's perfect. So the meter still need slight adjustment, but not so far. Okay, so let me do the same for the +6 volt, and after that I will adjust the meter. I think I have a problem on the 6 volt output, since I'm not able to bring the current to the 2.75 amps as it should. So I can only reach 1. Let's say 1, but a little bit less actually, and the minimum is 0.83. So it seems that the current regulation is not working as it should. It's a low level of current, and well, what I will do, I will leave with the load a little bit, because it also seems that it's drifting a little bit. So let's see the behavior, and after that maybe we need to crack open again, because I didn't test the 6 volt under load, and well, the behavior is not as expected. So let me keep this in a burn-in and see the behavior. Well, after I have checked the service manual, it's clear that I was mistaken trying to regulate the maximum current with the ammeter connected directly to the output, since the 6 volt range is working differently from the dual 20 volts. In fact, the 6 volt range, if feel a dead short, will limit the current to 1 amp, and that was exactly what I was achieving during the test. In the service manual, it is stated that for make a real current test, we will need a decade resistance capable to run up to at least 3 amps. But I don't have in my hand such powerful decade of resistors. So I have put one network, paralleling a lot of resistors. It was a really funny setup, which I'm not showing because it's not so professional to show, but at least I were able to reach 2 amps. And well, it seems that it's true, so the unit is working as expected. So I have reassembly the whole unit. Unfortunately, I don't have in my hand right now something to use to get illumination in the meters. Actually need a lead, a very small lead, because the space between the top lead and the meter is very low, so LED will be the right choice. So as soon as I have in my hand, I will do the modification, and probably I'll show in some next video. For the moment, I am pretty happy because the unit is back to work. As you have seen, also all the 4 fits are in the place. So the unit is not tilting anymore, and it's working as it should on both range. I mean, in all 3 ranges. This is the plus, and this is the minus. So I hope you enjoyed the video, and will be for some help to somebody which have the same problem. If you like it, please give me a thumbs up. So see you next time. Bye.